Let me change this a little bit. This is another node. This is connected to the ground. Let's say this is 5 volt. This is 10 volt. Okay, this is, let's say, 2 ohm, 4 ohm, 6 ohm. Okay. Now, first thing, we need to know how many nodes, how many intersections we have in this. How many nodes we have in this circuit? Say something. It's not difficult. You can. Okay, we have 2 nodes. Node where branches meet. So this is one, this is one. Let's look at this node here. This node, the voltage is 0 because it's connected to the ground. Okay. Now, do we know the voltage at this node? No. So we give it a name. We say this is, for example, V1. We don't know it. The nodal analysis, the goal is to find the voltage at the nodes. So the goal is to find the voltage here. Now, what is the voltage at this point? What did we say the voltage at this point here? Connected to the ground? 0 volt.
0. Yeah.
So what is the voltage here?
Same.
Still 0 because it's connected with the wire. There's nothing here. There's no drop or gain. 0 volt, you still have 0 volt, 0 volt, 0 volt. You go until here, there's 0 volt. And until here, it's a 0 volt. Until you get to the resistor. And until you get to the here, this is all 1 point. This is 0 volt here. Okay. Now, what is the voltage at this point here? So going
10.
from the 0, you're gonna gain 10, so this is 10 volt, right? What is the voltage at this point?
0.
0 is here. But if you go
5.
up, are you gonna gain? This is the positive, this is the negative. Are you gonna gain 5 or you lose 5?
Lose.
So this is minus 5 volt. Here you gained because you go from the 0 walking up. This is negative and positive. You gain 10 volt. So here you have 10 volt with you. While here you're coming from the 0, you're going from positive to negative. So you're losing the 5 volt. So you have minus 5 volt here. Is this okay so far?
Sir,
Yes.
can you repeat this part
It-
about gain and lose?
If you're going from negative to positive, even in real life, if you go from negative to positive, this is rise. This is you gain. If you go from positive to negative, this is a drop. Is that okay? I am at the 0
Yes.
voltage here. You go from negative to positive, you gain 10, so this is 10 volt. Okay, now the other side, you go from 0 to minus 5. You go from 0 and you lose 5, so you drop 5. So 0 minus 5 gives you a negative 5 volt. Is this okay so far? Now, What is the voltage cross this resistor? Let's say the voltage is, let me say positive here and negative here. What is the voltage across this resistor right now? Say this is R1, VR1. This is R2. Say that this is positive, this is negative, VR2. And that is VR3. Let's say that positive here, negative here. So what is the voltage cross the first resistor? This resistor. Okay, how do we know the voltage across a resistor? Let me help you. If you have a resistor like this is positive, this is negative, this is the voltage across it. In the voltage here is, let's say, 12 volt. And the voltage at this side is 4 volt. What is the voltage across the resistor? What's Vx here?
It will be 8.
Which is 12 minus 4, right? The plus side minus the negative side, right?
Yes.
So what about now this voltage here? The voltage VR1. The same idea. We're going to do the same idea. What is the voltage at this side? What is the voltage at this point? V1, right? We said it's V1. What is the voltage at the other side?
10.
So what is VR1?
5. 10 minus 5.
No. V1 minus 10. The voltage here minus the voltage here, right? We don't have to get the numbers. The voltage at this side, we don't know it. We called it V1. At this node, the voltage is V1. At this node, the voltage is 10. So VR is V1 minus 10. What about VR2? What is the voltage at this side of the resistance, the positive? Is this difficult?
V1 plus 5.
No, I want just one side first. It's the voltage here minus the voltage here, right? The positive and the negative. So
okay, yeah, for R2, I think you ask for R3.
Oh no, 2. So yes, so it is V1 minus the voltage at this side, which is 0. Now what is VR3?
V plus 3, V plus 5.
V1, yes,
plus 5.
minus 5, which is plus 5.
Yeah.
Is this okay, like the concept of the voltage? It's the difference between the voltage at this side and the other side, the difference between the voltage at the terminals. Even when you measure the voltage, you actually bring a voltmeter and you connect the positive this side and the negative at this side. So the voltmeter will measure the difference between the voltage at this point and the voltage at this point. Is that okay so far? It's important to know the voltage concept and the current concept. It's very important, and maybe it's a bit lacking. You don't have it from the fundamental one, but it's time to learn that whenever someone asks a voltage across something, It is the difference between the voltage at one terminal, the positive terminal, minus the voltage at the negative terminal. Is this okay, the voltages? Any questions? Okay, now I'm gonna go to another thing. What about the currents? Let's say that, okay. I'm gonna erase a few things here. I'm done with the voltages. I'm gonna do currents now. So what if I want to find this current? Let's say this is I1 in this direction. Current in a resistor equals what? Ohm's law. Current in a resistor. V over R. So I1 will be the voltage across the resistor, which is this voltage now, from here minus there. So it's VR1 divided by R1, which is V1 minus 10 divided by 2. Now I2, which is the current here, will be the voltage if I assume like it's in this direction. So V here minus V here, that is the voltage across the resistor, divided by the resistance gives me the current. So it's V1 minus 0 divided by 4. I3, if I assume it's going this way, will be the voltage here minus the voltage here divided by the resistance. So it's V1 minus 5, which is plus 5, divided by 6. Is the current okay now? Like current in a resistor, is the voltage across the resistor divided by the resistance. That is Ohm's law. Now what if someone says, okay, I'm going to change the direction of this current. Not this way. I'm going to say it's this way. What will be the current now? If their direction is in this direction. Can anyone give me the like formula for this current now? What is the voltage at this side? 10. What is the voltage at this side? See, now the current is going this way, so this is the positive, this is the negative. So the voltage here minus the voltage there, so minus V1 divided by the resistance, which is 2. So if I change the direction of the current, I change the signs here. It makes sense. If the current in this direction is 5, it's in the other direction minus 5. Is this okay? It's like I'm talking about something completely new. This is Ohm's law. Okay, so can I erase all this? I'll stay with my first current. This is I1 and this is I3. So to find the node voltage, here's now the technique. To find the node voltage, we apply at the node. So at that node, we're gonna apply Kirchhoff's current law. What is Kirchhoff's current law saying? The entering currents equals to the leaving currents. Now, how many currents are connected to this node? How many branches here? Guys, say something. I don't want to keep talking. It's not difficult to see that there are 3 branches connected. There are 3 streets connected to that point. So come on, say something. Should I just keep talking and that's it? I don't even know if you know this is called a node. Now, I don't even know if you know that there is something called current and voltage, because there's exactly no response. There's nothing. So how many currents are coming according to these 3 currents here? Any one of those 3 currents are going to the node?
V1
No,
equal.
they're not.
They're all leaving. You see that this is going away, this is going away, this is going away. So the 3 currents basically are leaving. So nothing is coming, but leaving all of them. I1 is leaving the node, going away from the node. I2 is going away from the node, and I3 is going away from the node. Now, this is equation. If I plug those values for the currents, I'm going to have for I1 is V1 minus 10 over 2. For I2 is V1 minus 0 over 4. And for I3 is V1 plus 5 over 6. Now this is equation. You can solve it to find the voltage V1. So this is the nodal analysis. The node analysis or nodal analysis is to find the voltage at the node. How do we do it? We do it by applying Kirchhoff's current law at the node. Entering currents equals to the leaving currents. It doesn't matter where you assume the direction. If you assume the direction this way, this will be entering. It will be moved to this side of the equation, and it will be in a negative angle. So the equation is going to be the same. So you assume the direction is the way you want. The equation at the end, it's not going to be in the current, it's going to be in the voltage. And the current is the voltage across the resistor divided by the resistance. We're going to go back to Ohm's law one more time. Please know Ohm's law, okay? Just do this. If the voltage at this node is a 12, the voltage here is 30. And someone says find V1 or R1 here. And they give you the polarity like this. What is the voltage VR1 here? Oops. What is the voltage VR1? The voltage across the resistor. What is the voltage at this point?
30.
Thank you. What is the voltage at this point?
12.
12. So what is the voltage across the resistor?
Thir- 30 minus 12.
30 minus 12. Okay, so it is 18 volt. Now, what if someone says, okay, I'm going to give you the question in another way. Polarity is like this. What is VR1 in this case?
+30 +12.
Minus
12.
30.
No, 12 minus 30. The positive is a 12, the negative is 30. The voltage here minus the voltage there. So it's going to be minus 18. So if you connect your voltmeter like this, positive here and negative here, it's going to read minus 18. If you connect the positive here and the negative here, it's going to read 18. Is this okay? The voltage concept is okay.
Yes.
Okay. Want VR2. And I'm going to put the polarity like this. Equals to what? What is the voltage at the positive side? What is the voltage connected to this side?
12.
12. What is the voltage at the negative side?
0.
0. 12 minus 0. 12 volt. If you change the polarity, it will be 0 minus 12. Is that okay? Now, this is called voltage, okay? And it's across an element. Just in case that you never heard of it in Fundamental 1. Voltage, I know you did Ohm's law, but it seems that it's too difficult. Even it's one of the easiest things, but what can I do? Okay, now currents. What is the current in this resistor going this way? Let's say this is I2. I2 is the voltage across the resistor. Now the current is
12.
going down, so it's the voltage across the resistor is 12 minus 0. Current is going down, so the positive here, the negative is here. So 12 minus 0, this is the voltage. If we divide it by the resistance, we get what? The current. Is that okay? Is this okay? Voltage,
Yes.
this is the voltage divided by the resistance. Ohm's law says, Ohm's law one more time, says voltage across a resistor divided by the resistance. Current hates the resistance. They're not both in the top. If one is in the top, the other one is in the bottom. So, okay, now what if I change the direction of the current? And I say, okay, find I2 going this way. In this case, I2, here's the polarity now. The voltage here minus the voltage here gives me the voltage across the resistor. So the voltage across the resistor is 0 minus 12. This is the voltage, not the current. When I divide it by the resistance, I get the current, which is 3. So here it's minus 4. When you change the direction, you get a negative answer. Okay. So what if I want the current in this direction, I1? What is the current here, I1? Can anyone tell me? Remember this law. So polarity would be like this. It's the voltage across the resistor, which is 12 minus 13 here, 12 minus 30 because the current is going from the 12 to the 30. So it's 12 minus 30 divided by the resistance, which is 6. Voltage divided by the resistance gives me the current. In this case, it is minus 3 ampere. If someone says find the current in this direction, it will be 3, not negative 3. because it will be 30 volt minus 12 volt. That is the voltage. This is the voltage, okay, which is the difference, divided by this is resistance. You can see it. This is resistance in ohm, and that is the voltage. And I cannot repeat it more than this. Like, this is quite too much time spent on the, I don't even know how to talk now, on fundamental one. Do you guys understand the voltage and current and Ohm's law? Can we go on to the lecture?
Yes.
Yes, sir.
Okay, so the can you see the lecture, the PowerPoint?
Yes.
Yes, sir.
So nodal analysis, it means we find the voltage at the nodes. Okay, the voltage is a difference between the voltage at the node and a reference voltage, okay, which is usually the ground. So nodal analysis, basically to find the voltage at the nodes. Okay, this is important. We miss the important stuff because we think of the other things that they're not important. Okay, so nodal analysis to find the nodal voltages. Okay, so what is a nodal voltage that we're gonna try to find? And when we find it, is that gonna help me to do anything? Yes. If we have the nodal voltage, we can find anything in the circuit. So what is a node? Is a junction. It's a point where branches meet. Okay, where branches get together, meet, okay? Now, one of the nodes, a circuit, every network might, if it's one loop, it doesn't have, in this case, a node, but a network might have so many nodes. When we do the nodal analysis, we're gonna choose one of the nodes as my reference, and we're gonna find the voltage at the other nodes. Here's the procedure. Not difficult. First thing, you're gonna actually find how many nodes you have, and one of them you say this is my reference. Usually the one that's connected to the ground. So you say this is my reference node. Then the other nodes, you're gonna assign them voltages. So you want to find those voltages. Because we're working at nodes, we're gonna apply Kirchhoff's current law, because Kirchhoff's current law is for nodes. It says at a node, the entering current equals to the leaving current. Okay, at any point, at any node, okay, in the circuit. Okay, so we're gonna apply this. It means the sum of the entering currents equals to the leaving currents. Then we're gonna change the currents. We're gonna express those currents in voltages, in the nodal voltages, and we solve those equations. Okay, example here. I'm actually gonna go to this. Okay. How many nodes do we have in this circuit?
2.
2 nodes. So first thing we do, we're gonna assign one node as a reference. So one node, we're gonna say this is my reference. This is the node that I'm gonna say this is my reference because it's connected to the ground and makes sense to be the reference. Anything connected to this node like this is still the same voltage. There's no drop, no gain here, nothing. So this is the reference and it's a 0 volt. We call it my reference voltage. This is the first thing. The second thing that we look at the other nodes, we only have one node here. And for the other node, we're gonna actually give it a name, V1, V something. Now let's call it Vn. The voltage at this node, this is what I want to find. Nodal analysis is to find the voltage at this node. Then, easiest way is to assume all currents are leaving. Now, if you assume something different, you're gonna get the same equation. So, currents are leaving, Kirchhoff's current law. It will say that entering currents to the node equals to the leaving currents away from the node. This node, I assume all the currents are leaving. So what happens? Nothing enters. The leaving are the 3 currents. Now, each current, I'm going to express it as a voltage divided by resistance. So the current going here is the voltage across this resistance divided by the resistance. Here's the resistance. The current going here, the voltage divided by the resistance. And the third current is the voltage divided by the resistance. Now, what is the voltage across the first resistance is the difference. Positive here, negative here, since I said it's going that way. So Vn minus 18. And here the second one, Vn minus 6. Because the voltage at this point is 6. And this one, Vn minus 0. So those are the 3 currents, voltage divided by resistance, voltage divided by the resistance. Voltage. Now the equation has one unknown, which is Vn. You can solve this equation whatever technique you want. I'm gonna multiply by the least common multiple, which is 12, to get rid of the fractions, those fractions. So when I multiply the 0 here, sorry. When I multiply by 12, this will be like 3 here. When I multiply by 12, it's 1 here. Multiply by 12, it's 4. So multiply by 12, 12 divided by 3 is 4. 1 and 3. The voltage at this side is 0. Sorry, Vn. Because I got a question why this one is not minus 6. The voltage here is Vn. The voltage here is 0. So the difference is Vn minus 0 divided by the 3. This one here, the second one, is Vn minus 6 because the voltage here is 6. Now I can simplify this one, 3 and 1 and 4, 8 Vn and 18, 54 times that minus 60 equal to 0. So Vn, you can solve the equation the way you want, it's up to you, equals 7.5 volt. Now once you did the analysis and you find the nodal voltage, خلاص, erase everything you did. I finished the analysis. The voltage at even those guys that I used. This is 7.5 volt. This is what I got. Now, if someone says, find the current in this resistor, where do you think the current will be going? In this direction or in this direction? To the right or to the left? See the analysis to get the nodal voltage. Once you get the nodal voltage, you finish the analysis. But you can use it to find so many things like voltages and currents and power in the circuit. So if someone says find the current of I and the resistor R1, so Vn is 7.5, which is here. The current in this resistor, forget about my assumption. Is it gonna go this way or this way? What is the voltage here at this point? What is the voltage at this point?
18.
Thank you. Why you guys don't talk? So say something at least so we can understand that at least 1 out of 27 is understanding what I'm saying. I feel like no one is actually getting what I'm saying. And sometimes I feel it's easy, but I'm just wondering why you're not getting it. Okay, the voltage here is 18. What is the voltage at this side? At this point? 7.5. So the current will be going to the right or to the left? The conventional current. Okay, let me do it one more time. The voltage here is 18. The voltage here is 7.5. Do you think the current will go this way or this way? You have two options, so just pick one and tell me. You can just say to the left or to the right, just say something.
To the left.
Right.
Okay, now conventional current. It's gonna go this way or this way. And a resistor, up or down?
Up.
Conventional current.
Down.
This is the positive, this is the negative, it's gonna go this way. So the current basically, it's gonna go from the high voltage to the low voltage from 18 to 7.5. It's gonna go that way. So what is this current here? It's 18 minus 7.5 from current here, voltage here minus voltage here. This is the voltage divided by 4. Which is gonna be 10.5, so 2.5, 2.6, 25, I think, ampere. Is this okay? If someone says, okay, it's gonna go to this way. Let's say someone is gonna go, say it's gonna go this way. What you're gonna do, you're gonna have voltage here minus voltage here. So you're gonna have 7.5 minus 18. This is the voltage divided by 4. So it's gonna be minus 2.5 or whatever, like that, ampere, sorry. So this guy got a negative number. It means that this direction is opposite. This guy got a positive number. It means this is the right direction for the current. But if the question says find the current in this way, you're going to give them the negative number because they give you the wrong direction. Anyhow, let's continue. Okay, we're going to do this example. So first thing is, how many nodes do we have in this circuit? How many nodes do we have in this circuit?
Two.
2 nodes. This is 1. Everything connected to it will have the voltage, let's say V1. This is another one, which is everything connected to it will have the same voltage. And we're going to select it as my reference. Then I'm going to use Kirchhoff's current law at this node to find the equation here and solve it to find V1. So the voltage at this point is 8 volt. The voltage at this point is actually minus 1 volt because you go from 0, you lose 1 here. You go from 0, you gain 8, so this here. If I assume the 3 currents are leaving this node, you can assume they're not leaving. That's okay. You're going to get the same equation. So current here is the voltage divided by the resistance. So now no current is entering, all currents are leaving. 1 plus 2 plus 3. Like this is 1, this is 2, this is 3. So now the currents is the voltage divided by the resistance. This one is going this way. So V1 minus 8 divided by 2. This one here, V1 minus 0 divided by 3. Then the third one, V1 minus 1, so V1 plus 1 divided by 10. Current, current, and current. Voltage divided by resistance is current. Voltage divided by resistance is current. Voltage divided by resistance is current. This equation, you solve it, you're going to find V1. Once you find V1, which is the voltage here, okay, you can find the voltage across this resistor, which is V1 minus 0. And this is here when we solved. Oops. This is the equation. I got the common factor. This is another way to solve it. You either multiply by the least common multiple to get rid of the fractions, or you take common factor as well. So common factor here, I did V1 over 2 and V1 over 3 and this is V1 over 10. I got V1 as a common factor, and I have 1 over 2, 1 over 3, 1 over 10, which is this. If you multiply V1 will be V1 here, V1 here, V1 here. Then the other one minus 8 over 2 and my plus 1 over 10. These are the two numbers. Move them to the other side, find this, you can find V1. Once you find V1 in this equation, the question says find this voltage. Positive is here, so it's V1. The negative is here, so it's 0. So it's V1 minus 0 gives you the voltage across this resistor. Okay. This is another network, and it's an AC network. We will stop here, but just an introductory to this one. There are 2 nodes. This is 1 node here. This is 1 node here. This node is going to be my reference node, and I'm going to apply Kirchhoff's law to this node. If I don't know the current, I'm going to assume it is leaving. Like the current here, I don't know it's leaving. The current here, I don't know. I'm going to assume it's leaving. But this current, I know it because see, there is a current source. So I know this current is going up and I know the value for this current. So if I know the value for this current and I know its direction, I don't assume anything. I just take it. It's coming. So for this question here, there are two currents are leaving because I don't know if they're leaving or entering. So I can assume whatever I want. And there's a current that is coming and I cannot assume it's leaving because it's actually coming. And if we go back to the here, just these steps one more time, you're gonna assign one node as your reference. The other nodes, you're gonna give them names, voltages. You're gonna apply Kirchhoff's law at those nodes, not the reference. The reference is 0 volt. We don't solve it. Then we're gonna change using Ohm's law, those currents, we're gonna change them into voltages. So voltage divided by the resistance. Assume the unknown currents, assume them they're leaving. That's easier for you. So if you don't know the current in a branch, assume it's leaving. If the current is known and given, khalas, you can't assume it leaving or entering. You have it as direction and you have it as value. And I will see you after some time at 3:30, I think.
Sir,
Yes.
the volt in the circuit, the one who down, we have V1 up and V0 down. Is it always 0?
Now you're gonna try to tell me something more than what you said. I did not.
Can you open the circuit picture?
Which one? This one?
Yes.
Or this one?
Yes, this one. V1,
Okay.
sometimes you put a number, but in the reference, it is always, you always write V equals 0.
Yeah. So the reference node, we always say it is 0 volt. This is my reference. So I'm gonna, when we say reference, it means we're gonna measure the voltage at the node compared to the reference. So if someone says measure the voltage at this node, okay, V1, let's say, you're gonna bring your positive of your voltmeter to the node, where you're gonna connect the negative of your voltmeter. You want the voltage at this node. Where are you gonna connect then? Here?
Yes.
No, you connect it to the reference point. You have to have a reference so you can say the voltage at this node compared to the reference is this value. So let's say that you have this. It has so many nodes. Okay. Whatever sources. And someone says find the voltage at this node. You have to know, okay, find the voltage at this node, okay, compared to what? We usually say compared to the ground or the reference, okay? So voltage at the point is always compared to the ground or a reference point. You can't measure a voltage at the point by itself. You can measure a voltage across an element like this. It's a cross. But at the point, you need a reference. This is why we have a reference point, and we assume it is 0 volt at the reference.
Okay.
And usually the reference is the ground, so the ground is always a 0 volt.
Okay, thank you, sir.
Okay, guys, I'll see you 3:30, something like that.